So far, we've been working with simple, linear node trees, and that's fine as we learn to use Resolve and get the hang of the tools at our disposal. We're now going to move on to understanding parallel operations within Resolve, and we're going to start with parallel nodes. Parallel nodes are simply serial nodes that are arranged in parallel and fed into a mixer. You can see a basic parallel node structure on the node tree here. These two nodes, arranged in parallel on the node tree, hence the name, will carry out their color adjustments at the same time as each other. The top node is making the grass yellow, and the bottom node is making the sky cyan. With this node structure, we basically have two things happening at the same time on our node tree, rather than just having two serial nodes carrying out their adjustments sequentially. But what is the point? We can just use serial nodes, right? After all, we're doing two totally unrelated things here, working on separate colors with no overlap. If I switch to a different version, here, you'll see that nothing changes. The two resulting images are identical. At first blush, this seems somewhat pointless. It appears to make a node tree harder to understand, and doesn't appear to offer any additional functionality. However, the reality is that parallel nodes are extremely powerful tools. We'll start by building a parallel node tree, and for this example, please follow along with one of the wall shots from the second practical project. Here we have one of the shots of the dancers against the wall from our previous project. In the real grade I produced for the client of this project, I used a great deal of parallel nodes in order to keep the node trees under control. We're going to reconstruct the example grade from the previous exercise, but this time we'll use parallel nodes to keep the node tree under control and easier to read. First, we'll take care of our basic primary adjustment, which is present in these two serial nodes here. We've then made a third serial node. Now, rather than make a fourth, we're going to hold Alt and hit P. This then makes a new parallel node and a new parallel mixer. Alternatively, we can right-click, choose Add Node, and then Parallel Mixer. A parallel mixer has at least two inputs on the left-hand side and one output on the right. Its job is to collapse multiple inputs down into one output so that that single output can be passed on to the rest of the node tree. A parallel mixer has no effect if it does not have at least one input. Now we can begin to isolate colors in our image. And I'm going to start with the yellow shirt, just like last time. And that's fine. And then we'll do our thing, we'll bring it up, we'll make it very yellow, we might brighten it a little bit. There we go. In the node below, I'm going to make my adjustment for blue. I'm going to key out the blues here. And then I'm going to do the exact same thing. Now here we have two serial nodes arranged in parallel which are being fed into a parallel mixer. What's happening now is that both of their adjustments are happening at the exact same time. Now here we have two serial nodes arranged in parallel being fed into a parallel mixer. These two serial nodes each contain color adjustments just like any other serial node. The difference is they're being fed into the parallel mixer, and this makes both of their adjustments happen simultaneously at the point of the parallel mixer in the node tree. Now, these nodes are carrying out their adjustments at the same time. We have our two inputs here, a top and a bottom. The order of nodes being fed into these inputs is not important when using parallel mixers. They all happen at the same time. If I switch these two nodes around, nothing changes, nothing happens, and nothing is carried out any differently. As long as you're using parallel nodes, the order in which nodes are fed into the inputs on the left does not matter. Like I said before, and like I've kept on saying, they all happen at the same time. Now, this has immediate benefits when organizing our node tree. We can now group up several nodes in the service of a greater, more complex goal. Rather than just having a long train of serial nodes and having to remember what these four are all taking care of, I just have to group up the four parallel nodes, and you can have a large number of parallel nodes in a single mixer. I've never hit the maximum here. If you want to add more nodes, just hold Alt and hit P, with one of the serial nodes being fed into the mixer selected. You can right-click the mixer node and you can hit Add One Input, and that will then give it an additional input. You can then right click, add a corrector, you can connect that corrector up manually, and then manually feed it into one of the inputs on the left hand side. I've not hit the limit for parallel nodes whilst in 6 years of doing this, so you can just keep going. Once I've done this, I know that there's a group of nodes which are all taking care of a particular goal. In this case, isolating strong colors and bringing them out can all happen at this point in the node tree, instead of taking up a whole kind of linear layer of the node tree and being quite difficult to read and keep track of later on. After this, I can then move on and make a serial node after the parallel mixer. Now, this is important. Make sure you have the mixer itself selected with the orange border, then hold Alt and hit S to make a node after it. If you hold Alt and hit S with one of the nodes being fed into the mixer selected, you're just going to make another node after that one that's still being fed into the mixer. You're not really going to be extending your node tree in any real way. Make sure you've clicked on the parallel mixer node, and then hold Alt and hit S, you make a serial node immediately after the mixer, and then you just carry on grading as if you were working with serial nodes. This is the main organizational benefit of doing this, but things get a little more involved. For now, try using parallel nodes to group up linear functions into larger groups that tackle a specific goal. The wall shots of the previous practical project are great for this. Try to keep your parallel functions from overlapping each other. Pull keys and use power windows that prevent your parallel nodes from affecting the same regions of the image. We're going to go over the overlapping nature of parallel adjustments in the next lecture. Once you've had a little practice, click on through to the next lecture when you're ready. So far, we've used parallel nodes to stack functions that don't overlap. The effect has been to cluster several serial nodes together to make our node trees easier to organize. This time, we're going to look at the more practical advantages that parallel nodes can bring to the grade. All parallel nodes happen at the same time, and when they overlap, the adjustments contained within mix with each other. I've set up a Venn diagram here. Each separate node contains a circular power window, and they all overlap in the center. Now I've made these red, blue and yellow to better demonstrate the nature of the overlap. Notice how when the blue and yellow circles overlap, the image becomes black and white again. This is because when we add two complementary colors in RGB color space, they neutralize each other. These two overlapping parallel nodes are taking place at the same time, so blue and yellow is being introduced at the same time, which means that the two nodes neutralize each other. Down here, we have an overlap between yellow and red, which makes orange, and blue and red, which makes magenta. Now, as I said before, the order of these nodes does not matter, they all happen at the same time, and this is only true for parallel nodes. The order of nodes is important in almost all other node tree structures. The end result of this overlap is that parallel nodes can blend together in a natural and subtle manner, and this can be an advantage in certain grading styles. Doing this can help hide overlaps and rough edges in secondary keys, but more importantly, we can use it to keep things looking natural and all part of a piece when making secondary grades. Take, for example, the look of The Discovery, which is a film available on Netflix. On the surface, it's a fairly standard colour contrast look. We have a cold background built around skin tones that stand out, yet these also blend in and don't look artificial. Now we can approach this the basic way by building a skin key and then making an outside node with Alt and O. Or we can set up two parallel nodes. We build a key on the bottom node to qualify the skin, and we do not make a key of any other kind on the other node. What we will do is we will use this node here to cool down our entire image, and then in the bottom node with the skin key we will counteract that only within the skin tones. Now, this doesn't give us the immediate separation we might have if we'd used an outside node to do this. As we counteract the cold adjustment with some warmth, we have skin tones that come to blend into their surroundings more naturally. They retain a hint of magenta, which is fine, because we're not going for the Hollywood-style super obvious colour contrast here. And after we've set up our parallel node, we can continue grading as normal to finish off the image and produce a finished grade. The end result of this is a more natural, less overt look for our project, which is very useful for projects that want to retain the subtlety in their use of colour, and it also goes a long way towards hiding difficult keys as well. Now we're going to take a look at an example of this done with the outside node method, and here I've got a still, and we might have to just go in here so we can see the difference. So here we have this magenta skin, which is made with the parallel technique, and here we have the outside node, which is much more yellow. It stands out a bit more, it's not as natural, it's not as convincing to me. So I find that in this case using the parallel node trick is much better because it keeps our skin tones kind of blending in with the coldness of the overall image. And this is just a simple way of using the overlapping qualities of parallel nodes in a creative grade. After this node tree, after this parallel mixer, I've then got some more contrast. I've got a vignette on the face because he was shot against the light a little bit here, so I've brought his face out. And then I've got a vignette on the left hand side just to really focus you in, because this is quite a reflective, quite a kind of calm shot. So we just want that kind of level of focus and kind of introspection here, which has been achieved by adding that vignette. So this is a very simple rendition of this look. More work would obviously go into it if it were for final delivery. But this is a nice example of how the overlaps in parallel nodes can help us whilst grading creatively. Because obviously without that, it goes completely cold and he almost looks dead, looks a bit like a zombie. And this just brings back some more of the quality of the skin, and we can see that that's a reasonable facsimile of the look in the discovery here. So that was one example of overlapping parallel functions for creative purposes. We're going to cover another one, and this straddles the line between our creative overlap and the organization techniques from the previous lecture. Here I've got a shot with a skin key placed after a primary node, which is what we usually want. We get the image in a good place and then carry out our more detailed work. The problem with this is that if I want to change the primary grade, it's going to affect my skin key. So if I do anything here, let's say if I do something quite extreme, I'm going to lose my skin key in the next node entirely, which means that if I need to make an adjustment to this primary node, I'm then going to have to either adjust my skin key or place another node down afterwards, which will act as a primary adjustment. An alternative solution to this is that I could set my skin key up in parallel to this primary node. If I load up the other version here, now I can pull the skin key and get it just how I want it, and nothing I do on the node in parallel is going to affect that key at all. I could do the most extreme adjustment possible, and the skin key on the parallel node is not affected because it's taking its input from the first node, which is not being changed. There was a skin key on node 5 here, and we can see if I change anything on node number 2, then I actually lose the skin key on node number 5. So what I've done here is I've set up a simple system that allows me to make these primary adjustments without interfering with my skin key. So what I can do is I can sort my contrast out here, and then I can also change my skin tone, and the two operations are going to blend into each other, and anything I do is kind of carried over into this operation but does not interfere with the key itself, which makes this extremely powerful. So just a quick recap of why this works. We have node 1, which is where I've done my basic primary grade. That's now feeding into node 2 and node 4 at the same time. They're both receiving the same input. These two nodes are in parallel, so their effects both resolve at the same time, but they don't have a direct impact on each other. So if I've pulled a skin key in node 4, and I've made an adjustment in node 2, whatever I do in node 2 is not going to affect the key I'm pulling in node 4. However, it's going to affect our end image because the two adjustments still collapse into each other and are resolved simultaneously at the point of the parallel mixer. Now this gets quite difficult to explain and it gets quite difficult to wrap your head around, but in practice it's quite simple. Now that I've got this part of my grade sorted, I can continue and I can carry on grading. Just as normal, I can do some eye masks. All of that good stuff. So the advantage of doing this is that I can now make constant adjustments in this node without undermining my secondary work in the node below. So here we've had two good solid examples of overlapping parallel adjustments. Parallel node usage marks a more advanced style of working within Resolve, and this is what we're gunning for at this point. What we've covered so far would fall into the category of basic user training, and we've now reached the start of what I consider to be the intermediate phase of user training for DaVinci Resolve. The true potential of parallel nodes will become apparent as you work with them. Keep experimenting and trying different things to see how different adjustments blend with each other in this way. We're now going to move on and cover layer mixer nodes next, so click on through to the next lecture when you're ready. Now we're going to cover layer mixer nodes. These might seem similar to parallel nodes at first, but they have some key differences. A layer mixer is a node that takes two or more serial nodes arranged in parallel and then mixes them down into a single output at that point in the node tree. Now, layer mixers work very differently from parallel mixers. You can see the old Venn diagram here. This is the same diagram from the previous lecture, but on a different shot. It's been set up with parallel nodes. We can see how the different nodes blend into each other. Now, if I switch shots, we have the exact same thing, but this time set up with a layer mixer node. Notice how the adjustments do not blend together when they overlap. In fact, when the power windows here overlap, they don't blend in at all. They stack up, and one node is clearly on top, and the others are clearly beneath it. In this case, the green circle is on top, the blue circle is in the middle, and the orange circle is on the bottom. This is one of the key differences between parallel and layer mixers. With parallel mixers, the input order of nodes does not matter as they all resolve simultaneously. With layer mixers, the input order of the nodes does matter. The nodes that are fed into the layer mixer become layers, hence the name, just like a layer stack in Photoshop. This means that the top layer, which frustratingly is the bottom node, will be placed on top of all the other layers below it. That means that if it overlaps the layers below it, they do not show, and it does, because it is like it is physically on top of a stack of postcards. And just to make the order of nodes and layers super clear, the node going into the lowest input on the left-hand side of the layer mixer node becomes the top layer of that particular layer stack. We then work our way up until we reach the top input on the left-hand side, which is actually the bottom layer on the stack. Layer mixers essentially have it upside down. It's really frustrating, but that's the way Resolve is made. So here, the bottom node is the top layer, the middle is the middle, the top node is the bottom layer. So green is on top of blue, which is on top of red. This, like the parallel nodes, does not immediately make its practical value obvious, but layer mixer nodes are extremely powerful. They are not used quite as often as parallel mixers, and they have more specific uses, but they remain an extremely powerful tool. We're going to go through the basic usage of a layer mixer node. Now here I've already prepared a fairly standard color isolation look. It's a black and white background with preserved strong colors, which we might recognize from something like SimCity. Now this can be done with outside nodes, which is the old Alt and O trick. And to do that here, all I've done is I've made a node, I've pulled a key on the red shirt, and then I've held Alt and hit O to make a node immediately after that, which works outside of the key in the previous node. You can see we have our alpha output going to our alpha input here. This now means that the adjustments within node 3 only take place outside of the key within node 2. And here I've used this effect to make a black and white background with the red shirt preserved. Now, this effect can also be done with a layer mixer. All we have to do is set up a layer mixer node with two serial nodes acting as layers. This is easily done. We hold Alt and hit L. And a second serial node will be added below our current node, and a new layer mixer will be automatically added after that. Also, as with all of the node types, we can right-click, choose Add Node, and then go to the appropriate node type. The layer mixer node treats the bottom node, which is the node feeding into the RGB input on its bottom left, as the top layer, and then works its way down as we work up the mixer. I know I keep on saying this and I keep on repeating it, but it's really important that that sinks in, that the layer mixer is essentially upside down when it's ordering its layers. Now, we don't see any change here, as we haven't made any adjustments yet, but if we choose our bottom layer, we see that no matter what we do, we cannot see the result of the adjustments we're making. This is because there's a layer above it, and that layer has no transparency. It covers the entire screen. So no matter what we do to the bottom layer, the top layer will always cover it, and we cannot see what we've done. Now, we'll make an obvious adjustment to this bottom layer, and we'll leave it like that. I'm going to go to the top layer, which is the bottom node, remember, and I'm going to make a power window. I'm going to make the left half of the top layer become transparent. And now you can see the layer beneath on the left-hand side and the adjustment we've just made. Where the top layer is transparent, we can see the layer beneath it. Don't worry if the practical value of this is not obvious yet, we're just about to go through it in a real grade. I'm going to reset these two nodes, and we're going to go back to our color isolation look, our kind of SimCity look. Back to our color isolation look. We've got our first two serial nodes fed into a layer mixer. We haven't made any changes, so the first thing I'm going to do is go to the bottom layer, which is the top node, and set the saturation to 0 to make it black and white. We haven't seen any changes in our final image yet, but we will soon enough. I'm now going to go to the top layer, which is the bottom node, remember, and pull a key on the red shirt. Now, this key then acts as an alpha channel on this node, telling it to be opaque in the places where it is keyed, the red shirt, and transparent in others, anywhere outside of that key. What we can see here is that our top layer is only visible inside the key we've pulled, so we can only see the red of the shirt. Outside of that key, we see the layer beneath it, which is now black and white. The end effect of this is a Sin City style color isolation look. We could have done this with an outside node, as I showed you before, but the key advantage here is that we can easily add additional layers to this layer mixer, and also key out other colors to keep. Take the yellow of the shirt, for example, or in this case the blue of the jacket. I'm going to hold Alt and hit L, and now I'm just going to key out that blue jacket. I'll make a better key than that, that's a bit slapdash. I'm going to take out the low sat stuff, and we're going to increase that. There we go. Clean white, blur, and clean back. This is going to be a bit of a messy one, but just for demonstration's sake. Doing this would otherwise require a key mixer, and produce a very impractical and complex node tree that would be difficult to navigate once we start making detailed tweaks. The layer mixer node allows us to group up all of these nodes together for this effect, and keep everything organized relatively easily. We could also apply this logic to building a color contrast look. If I were to key out the ski on this image and place it on the top layer of a mixer, which is precisely what I've done, I've then tinted the layer beneath it blue, and we have an easy way to keep a color contrast look without resorting to the harder to organize key mixers and outside nodes, which may end up delaying us later. This is the most basic use of the layer mixer node, so have a crack at it and see what you can do. The next thing we're going to tackle is blend modes, so click on through to the next lecture once you're ready. We've covered how to make use of alpha and overlapping with the layer mixer node. Now we're moving on to another very powerful feature, blend modes. Now if you have any familiarity with Photoshop, you'll already know what blend modes are, and they're present within DaVinci Resolve. If you don't already know what blend modes are, then don't worry, that's precisely what we cover in this lecture. Blend modes only really work when we have a layer stack and at least two layers in that stack. A blend mode is applied to the top layer, and then that changes the way in which the top image interacts with and changes the values of the images underneath. Our default blend mode is normal. This means that any visible pixels on the top layer show up, and the pixels beneath them do not. The top image basically sits on top of the images underneath. Alternative blend modes change this. We can make the top layer act like light or shadow. We can use it to stretch out the contrast of the layer beneath, and a few other things as well. We're going to cover a few basic blend modes and then move on to how we might make an archetypal bleach bypass look. First, we're going to cover Add and Screen, and if you want to change the blend mode being used by a layer mixer, you right-click the layer mixer and choose Composite Mode, and then from this list, you choose the blend mode that you're looking for. So firstly, we're going to cover Add and Screen. These two blend modes behave in a similar fashion, though the math is quite different. A top layer set to add will simply add its values onto the layer beneath. In additive color space, such as RGB, this makes the image underneath brighter. The brighter the pixel on top, the brighter the pixel underneath is made. Screen produces a comparable end result, but is gentler and is a better choice for a more subtle, believable look. Add by itself is a bit of a blunt instrument, and we usually have to tweak a top layer and lower its opacity in order to get the most out of it. Screen, in particular, can be useful in making a dreamy glow look, often called a screen blur, which is popular for flashbacks and dream sequences. To do this, we work on our top layer, and we're just going to reset the blend mode here. And before we set our blend mode, we go to our blur and sharpen tools, and we blur our top layer out quite a bit. We then set the composite mode, or the blend mode, to screen, and we can then go in and adjust the opacity to finish off the effect. and we get a kind of a dreamy, glowing look, which is very good for flashbacks and dream sequences. The next blend mode is multiply. As the name implies, this takes the values of the top layer's pixels and multiplies them with the bottom layer's values. This, counterintuitively, results in a darker image. Multiply is not used as often, but can yield some interesting results when making darker pictures. Multiply may be useful when trying to work on a day for night, or when you're trying to artificially bring the lighting of a scene down. The final blend mode we're going to cover is the overlay blend mode. This one is used with reasonable frequency as it lies at the heart of the popular bleach bypass look. Overlay essentially combines two different blend modes, multiply and screen. When using the overlay blend mode, the midpoint of our tonal range, our 50% grey, has no effect, but everything that is darker than this 50% grey uses the multiply blend mode, which makes things darker, and everything that is brighter than 50% grey uses the screen blend mode, which makes things brighter. The end result is that overlay stretches out the natural contrast of an image. This makes overlay very useful for punchy, dramatic looks, such as the bleach bypass. We'll cover that in an example. So here we have our basic primary grade and we have two blank nodes feeding into a layer mixer node. We're going to leave our bottom layer alone. We don't need to do anything to that. Our top layer we're going to make black and white. We're now going to set our blend mode to overlay. And this is a start, but it needs some tweaking. We're going to have to bring the opacity of our top layer down somewhat, so that we don't lose details, and then, let's say 6.5, and then we're going to tweak the mids until we're happier with the result. And we'll just tweak our kind of contrast there, bring our highlights down a little bit, actually bring it up a bit. There we go. So this is a basic bleach bypass look which is characterized by having very low saturation and very high contrast. It also tends to exaggerate grain or noise in the case of a digital camera, so it's best used with some discretion. You need to be aware that you're kind of degrading the image a bit when you do this. However, for a kind of a grungy look, for a kind of a military look, for the look of a thriller, the accentuating the grain or even the noise might actually work because it helps kind of get that grit and that texture along in the image. This is the basic bleach bypass look. It mimics the layer of silver crystals left on a roll of film if the bleaching step is skipped, and the end result is an image of strong contrast and desaturated colour. This has been a good intro to blend modes, but the real potential here lies in experimentation. Have a crack of all of the footage you've got and see what happens. Now, the best bet here is just throw stuff at the wall and see what sticks. You might find something that you really like. In the next lecture, we're going to cover one of the most interesting new features of Resolve 15, which are shared nodes. Click on through to the next lecture when you're ready. Resolve's version 15 update came with a big new feature, the shared node. These are really powerful and change the way in which we work on groups of shots quite considerably. We've been through how to place shots in groups before. When we do that, we can then place nodes that affect all the shots in that group at the same time. Shared nodes are similar to this, but there's a very important difference. Shared nodes are shared across multiple shots, but do not require those shots to be in the same group. A shared node can be created and placed in multiple node trees. It will apply the same adjustment to all of those node trees. If it is changed or deactivated in one of those node trees, that change carries through all the other node trees which contain an instance of that particular shared node. This means we can set up a node that takes care of noise reduction or a vignette in a particular way, and then apply those adjustments with a simple right click. We no longer have to manually delete all but one node, take a still, and then use the append node graph option. Now, we can save any node we want as a shared node. All we need to do is right click and choose Save as Shared Node. Now, by default it's given the name Shared Node 1, and that's not ideal. What we want to do is right click and change label, and we're going to give it a name. In this case, it's going to be Magenta. We can then move to a different shot, and what we can do is we can just right click, add node, and then at the bottom of this node list we have our shared nodes saved and referred to by their name. Obviously you're going to possibly have up to 20 odd shared nodes in a big project. We're not going to leave them all at, shared node 1, 2, 3, whatever. We right click and choose Magenta, and now our Magenta shared node appears. Hang on a second, this node tree is being awkward. We'll just reorganize that 1 second. So now our shared node is right here. We can just drag it into the node tree, and lo and behold, we have the same magenta correction on 2 shots. So let's say, for example, we're working on 2 shots that are taken from the same angle, but we've had a lighting change for whatever reason. Let's say the sun has moved, or the camera settings got tweaked, whatever. We can get them in the same place using our primary grades, but save a secondary grade as a shared node. We can then just apply it to the second shot instead of having to redo that secondary from scratch on that second shot. We could also do the same for static circular vignettes, which may fit for these 2 shots, but it may not be suitable for others in the edit. And we can also use this method to apply noise reduction as well. Now, a few notes on shared nodes. They are all effectively the same node appearing in different node trees at the same time. This is not like copying and pasting a node onto something else where you can then change it. If you make a change to a shared node, all other instances of that shared node are changed in the exact same way. And if you turn a shared node off in one tree, and I'll do that just here, that shared node is then deactivated on every other shot in which it is present. So if you decide that a shot isn't going to use a shared node, you need to delete it from that node tree. Because of this, shared nodes become locked by default. You have to right-click them and choose Unlock Node or Lock Node to toggle it off, and then you can make a change. Shared nodes are a very powerful feature, but they're also new, and people are still figuring out the different ways of using them. Experiment and see what you can come up with. We have one last lecture in this module before we move on to our next practical project, so click on through to the next lecture when you're ready. We're now beginning to work with 4K and RAW files, and if you're working on a laptop or a MacBook, you may find that things are playing back slowly. Color grading takes a lot more technical grunt than a standard offline edit, as we need to work with the camera RAW files and files at full capture resolution. We can no longer rely on convenient proxies to spare us the need to use expensive equipment. There are workaround measures for this though, and one of them is the render cache. We're going to take a look at how we might preserve real-time playback whilst working on complex grades that might otherwise cause us to lose performance. Here I have a 4K R3D clip. It's playing back in full res at full debayer. We're going to go over that in the next real-world project. However, if I play it back, you'll notice that I'm not playing back at 25 FPS, I've got about 13 here. And that's because I've whacked a fairly heavy noise reduction operation on there. I've done that specifically to make something that would slow this workstation down so that we have something we can use for this demonstration. Our aim here is to use the render cache to get this clip to play back at 25 frames per second. The render cache is a very useful and powerful tool that allows us to pre-render certain aspects of our grade, and then play those rendered files back to view a complex grade in real time. This allows us to see the results of intensive effects like blur or noise reduction in real time, when that would not otherwise be possible. First, we need to set our render cache up. Our render cache always goes to the first media storage location we have set by default, and this is not normally the best choice. If this does not have adequate space, we will not be able to cache much footage. On most single drive systems like laptops, this isn't too important as there's only one drive to choose from, but on multi-drive systems like workstations, it's very important indeed. Ideally, you should have a dedicated SSD drive for this, as that will improve your performance. We're going to change the render cache location, and we can do so quite easily. We're going to click in the gear in the bottom right of the screen to open our project settings up, and then we're going to go to the Master Settings tab. And here we're going to scroll down until we see Optimized Media and Render Cache, and below it, Working Folders. In the Working Folders section, we're going to hit the Browse button next to Cache Clip. This is how we set up the location of our cache folder. Here, I've got the cache location set up on my D drive, and that is absolutely fine for this machine. When setting your render cache location, it should be on a fast drive with a reasonable amount of space available. Whilst we're here, we can also choose the codec of these cache files generated by Resolve. Here it's defaulted to uncompressed 10-bit, and that is extremely inefficient for drive space. I'm going to change this to DNxHR HQ. That strikes probably the best balance between being efficient with the drive space we have available and giving us a good quality cached image. If you have serious space concerns, I'd recommend choosing either DNxHR SQ or ProRes 422LT. These are both good enough for cached images, and they make more efficient use of the space on your drive. I'm then going to hit Save to save these. Once we have our render cache set to the appropriate place, we can then enable our render cache whilst working. This is very simple, and we can switch our render cache off and on and even purge all cached files to restore space to the corresponding drive, all whilst working in the color panel. If we've made a grade which slows our machine down, like I have here, we just have to enable our render cache, then let that grade render out in the background. We do this by clicking on Playback up in the top left. We then go to Render Cache and we can choose either Smart or User. Smart will automatically detect the operations that are slowing your machine down. Then it will cache those individual nodes in order to speed up your workflow. What you can see is we have red numbers here. A red number indicates that something is queued to be cached. Once the red number turns blue, it has been cached and will play back in real time. Resolve is now going through and caching all the clips and nodes that need to be cached in order to play back in real time. Rendering a cache out for a 4K clip can take a few minutes. We still end up losing some time, but what we can do is we can continue and we can grade other things whilst the slow clip is rendering in the background. We can then return to it when it's cached to view it in real time. Now, the red number on our third node here has gone blue, showing that it has now been render cached. If we play this clip through, what we will see is that it does now actually play back in real time, whereas it did not before. This is a useful feature, but it does always take a few minutes for the system to catch up. Smart can be useful, but especially on lower spec machines, it can be a little overzealous. And what we saw here was all of these clips being cached when they didn't really need to be cached. It was only this one clip I'd graded that needed to be cached. So now we're going to go over the second form of render caching, which is the user setting. The user setting allows us to manually designate nodes or entire shots to be cached. To do this, we click on Playback, then Render Cache, and then User. Once we have this active, we can choose any individual node or any clip, and we can make it render cache manually. To do this, we just have to right-click and choose Node Cache On for a node, or Render Cache Color Output for a clip. What we will then see is that the number will go red, and then the render cache will take place, and when it's blue, it will then play back in real time. And then we can play this back, and it is now playing back in real time. This is useful for shots which need a lot of noise reduction or for very high resolution shots. It gives us more control over what is cached and therefore makes much more efficient use of our render cache drive space. However, it's time consuming to go through and choose individual things that need to be cached. It is down to you as to what the best setting is to use here. What you may well find, especially if you're working on a laptop, is that setting your render cache to smart is just going to completely swamp your drive with cache files as it tries to render cache everything. It may well be better to try the user version of render cache and then manually mark up clips which are playing slower than others. That way you retain control over how much of your drive is being used. The last thing we need to cover is the purging of the cache file location. Cache files take up space, and when we run out of space, we lose our ability to cache nodes and clips. In order to manage this, we have the ability to purge our cache files. This erases them and allows us to free up space in our cache folders. This is easy to do. We choose Playback, and then there is a setting called Delete Render Cache. We then have three options: all, unused, or selected clips. All will wipe all cached files for the project which is currently open. Unused will wipe all cache files that point to clips or effects which are no longer being used on our timeline. And selected clips will wipe all cache files for the clips you have currently selected. You will have to either control-click or command-click multiple clips, and then choose the selected clips option in order to delete the render cache files for multiple clips at once. Now, the cache files you generate will stay in place even after you close a project, so once you're definitely finished with a project, you've made your final delivery and you're done, make sure you go back into it and delete the render cache for that project with the Delete Render Cache All option. This will prevent you from running out of space on your scratch drive or your render cache location. Now, this was a good intro to the render cache. There's more to it and there is more to understand, but this will allow us to work with the next project quite easily. We'll return to the subject of the render cache in later lectures once we've reached the advanced stage. We're now ready to take on the next practical project. Click on through to the next lecture once you are ready.